Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Dutch Chaos Loop by GDC. Here are the rules. We have chaos construction rules where we need to divide the grid into orthogonally connected regions such that each row, column, and region contains the digits 1 through 9 once each. So to make an orthogonally connected region, first of all, they have to all be 9 in size. And because there are 81 total cells, and to make a region have digits 1 through 9, you need the digits 1 through 9, obviously, in the region. So orthogonally connected regions means that you can go from any cell in that region to any other cell in the region, staying within that region just by going through edges. So this is a valid orthogonally connected region, because say you wanted to go from this cell to this cell, you can just by going through edges and staying within the region. This is not valid, though, because to get from this cell to any other cell in the region, you would either have to go outside the region, or you would have to go through a corner, which is not allowed. So that's a chaos construction rule set. We also have a Dutch loop, where we need to draw a loop of orthogonally connected cells. And the loop can't touch itself, not even diagonally. So orthogonally connected cells on a loop mean that every cell on the loop can only share an edge with exactly 2 other cells on the loop. And it cannot touch itself diagonally, except if it shares a neighbor. It shares an edge or neighbor with another cell on that loop. So, for example, these can share a corner because they share a neighbor here, right? And obviously, these share a corner because they share an edge, so that's valid. And this is part of the Dutch whisper loop. Adjacent digits on the loop differ by 4 or more. And so, for example, if this were, say, a 3 here, this would have to be a 7, an 8, or a 9. Because the only digits which are 4 or more away from 3 are specifically 7, 8, and 9. We also have region borders divide the loop into connected segments. So this is, for example, a connected segment. And that's important because circle digits are on the loop. So these are guaranteed to be on the loop. And they count the number of cells on their segments. So, for example, well, I don't really want to try solving it, but this basically, say these two are connected, right? Well, okay, it's kind of solving it too. But if this were, say, a 3, okay, let's actually use this. Say this was a segment. This would be valid to have a circle around it because the segment length is exactly 3, right? It's 1, 2, 3, and then it goes to a boundary. 1, 2, 3, then it goes to a boundary. This could not be a circle digit because it has 8, and obviously the loop size is not 8. So that's what circle digits. And remember, circle digits are on the loop. And they count the number of cells on their segments. That's actually very important. And again, some region borders and loop parts are given. So this is a region border, this is a region border, so are these, and so is this. And this is a loop cell. So that's why we knew this was part of the loop. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we know the circles are on the loop. And because they are in the same row, and these must be orthogonally connected because they're in the same one. Where does this cell go, then, to be on the loop? It has to go that way. Well, this is also on the loop, so it's guaranteed that it has to go this way because it can't go that way because it would touch itself. So this is not on the loop here. This is on the loop here. This must be on the loop here and then here. So we know there must be a border, okay, here, and there must be a border here. Let's go the full border around the grid. This is a region here. And again, the reason why we know this is that these cannot be the same digit. And if they are in the same segment, they would have the same digit in them because they count the number of cells on their segment. So these have to be different segments. Therefore, we know this region must go this way. This is a separate segment, so this is going to be medium. I will color that. This is a separate segment, so it's green. This could go either this way or this way. So this is going to be a 2, guaranteed. This cannot double back here. It has to go this way as for the loop. And it's at least, this cannot be 2, so this has to be at least 3. It could go down this way if this is part of it, so we don't know which way this goes. This could technically be 1, so we don't know about that one either. There's a boundary between these circles. This could do something like that. That is possible to be on. Okay, so, oh, this has to be. This is the Dutch whisper loop. So we know this is 2. This has to be at least 4 or more away from 2. So this is 6, 7, 8, 9. This is 6, 7, 8, 9. So this, on this segment, must be 6, 7, 8, 9. And it cannot touch this. It cannot be in the same region as this. So this sort of, it cannot go this way, because then this would be the same segment, or this would be a very short segment here. And that's not possible. So this has to go this way. And it has to go this way, which means the light has to go this way. The green has to go this way, and it's 4 or more away from 6, 7, 8, 9. So this is 1, 3, 4, or 5 here. This is a boundary. 1, 2, 3. If we tried going this way, it has to connect to this. So that doesn't work. 1, 2, 3, 4, 5 doesn't work, so it has to go down again. This cannot be then part of the region, so this must go here. So this is at least 3. This can't be 6 then, because it has to be between these two. This is 1 through 5 here. Cannot be 2. So it could be 1, 2, 3, 4, 5, 6, and then go back here. We don't know. This region continues this way. It has to continue this way, so this green has to go here. It has to go down to here. But this has to go this way, because it has to be at least 3. And since it's here, it must connect to that circle, otherwise it would be touching itself. So this must go that way. So this is 3, because this can't be the same region, because otherwise this would be 3 also, and that would be the same region, and that's not allowed. So this has to be... I mean, basically they can't be the same segment, because they would be part of the same region, and have the same digits. So this is bordering this, therefore the green has to continue on that way. This goes to one of these two, there must be a border here. So this is at most 1 or 2. Because it has to be connected to this cell. this would touch itself diagonally, so this has to go that way. And it must be part of the gray region. The medium gray region. It cannot go this way. It could potentially go, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Potential, no. Since it goes here, it has to go to here. This can never go this way, so this has to go this way. Therefore, this must go that way. This must connect here, because otherwise it would be touching itself if it goes somewhere else. So this has to share that way. Then this is 1, 2, 3, 4, 5, 6, or 7 in the size. So this is 6 or 7. This cannot be 5, this cannot be 4, it's 1 or 3 here. This is 5 through 9 here to be next to it on the German whisper, or the Dutch whisper line. So these all must be gray. 1, 2, 3, 4, 5, 6. This cannot be, this is at most 3. So this is 1 or 3 here. That means this must be 5 through 9. This must be 5 through 9. That means this is either 9 or it's 1, 3, or 4. Hmm. This has to be, we don't know. It could be 1 through 5 or 9. Cannot be 3, obviously. Hmm. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, technically. Hmm. Ah, we have a 1, 3, 1, 3 pair in row 1, which eliminates 1 and 3 in the rest of the rows. This can't be 1 or 3. This is 4 or 9. Either way, it cannot be part of the same segment as this, because again, you'd have duplicate digits in the same set region, which is not allowed. So how can this ever be 9? I think the answer to that is no. Right? This is guaranteed 1, 2, 3, 4, 5, 6, 7. And that's the most it could be. So this is 4 then. So we are guaranteed this is a 4. Could be 1, 2, 3, 4, and then this is a set different segment. It can't go this way, because then this has to connect that way. So this has to go that way. This is its own region. We're going to make this dark. And I guess we can make this pink. So this is its own region. It must exit out. So it has to exit out that way. So this is pink guaranteed. It cannot go this way again because this would be 1, 2... I guess it could be. Okay, so it doesn't actually have to go that way. Apologies, that's wrong. It could be 1, 2, 3, 4. Or 1, 2, 3, 4. That's possible. This, though, is pink. We're going to make this dark. This does have to go out to form a region, so it has to be pink that way. This is between 1 and 3 and 4, so this must be 8 or 9. And this could go this way. This is a separate region too. And this must be a separate region also. But it could be dark region again there, right? Like this could be light again. Rest of row 1 has to be 5 through 9. Hmm. Hmm. This is 3. It must be next to 7, 8, or 9 here. So I think this must be 9, 5, and 1. If this is a low digit, that doesn't work. So this must be 9, 5, and 1. So this is one segment, and then it's done. So this is very likely the light region. And then it's done. That means this can't be 9 here. The rest of column 1 has to be 1, 4, 6, 7, 8. Okay. That means whichever cell this is must be a low. Or it could be, I guess, 9. This could go 1 to 5 and then 9. So this is 2, 3, 4, or 9. Actually, it could be 1 also. 1's very possible also. Unlikely, but possible. So this is either pink or medium gray, and this is pink or dark gray. We don't know which. 5, 6, 7, 8, 9. It could be a low. So 1, 2, 4, or 5, or it's 9. Okay. What is the size of this? We can go 1, 2, what's the most? 1, 2, 3, 4, 5, 6. So it could be 1, 2, 3, 4 here, and this is 1, 2, 3 at most. So this is not 1, 2, or it can't be 3. This is at most a 2. So since this is 1 or 2, this is 5 through 9 here. It cannot be 9 because of the 9 in the row. Hmm. Hmm. There's no way this can be 1. If this is 1, this is not part of its region, and this is not part of its region, but then this region can't get anywhere. So this has to be 3. So this is, since this is 3, this is 1, which means these are both pink. So since these are both pink, this dark has to go this way, because otherwise this is only 3 in the region, so it has to go this way. Same here. It has to go here, and then here. And then that's the dark region. And then it exits out. We don't know which way, but it exits out. Therefore, this could be still 2 or 1, technically. This is between 7, 8, and 9. Therefore, this can't be 9, 5, or 4. That could be 4. Actually, it could be 1, 2, 4, or 5 here. This could still be 5, 6, 7, 8, 9. This is 1, 2, 3, 4, 5, 6. So that's 6. This is a border here. This is a border here. It has to go this way, then this way. So this must be 9, then 5. That's the only combination of left, right? Because this digit's 4, it must be between 8 and 9, so that's 9, and this must be 5, which forces this to be 1. This 9 eliminates 9 here, so it's 8. This can't be 6, 7, 5, 6, 8, or 9, so it's 7. This 8 eliminates 8 here. This can't be 6 in this medium gray region. It can't be 1 because we are guaranteed this is 6 and 1. This 1 eliminates 1 here. This is done in its region. It could go this way, in which case, yeah. This can never be 5. Neither can this. If this is 5, it would have to be between 9 and 1 in the region, but we already have a 1 in the region. So this can't be 5, and this can't be 5. This can't be 9 either, because if this is 9, that would guarantee that this is a 1 through 5, and 1 through 5 is not 4 or more away from 2 and 4. So this has to be a 2-4 pair here. Since this is 2 or 4, this can never be 5. It has to be 7, 8, or 9. We have a 7, 8, 9 triplet in row 2, which eliminates 7, 8, and 9 in the rest of the row. So this is 2, 3, 4, 5, 6, 2 through 6, 2 through 6 here. This 2-4 pair eliminates 2 and 4 in the rest of the row, so this can't be 2. This is a 1. That's interesting. So this is 4 cells here in this segment. We have another one that's a single cell, and then another one that's a single cell. That's interesting. Rest of row 3 is 5 through 9. This can't be 2 or 6 here. So no 2, 6. This can't be 6 because of the 6 in the column. This cannot be 3 because of the 3 in the region. This can't be 4. 2 and 4 can only... This can't be 6 because of the 6 in the region. 2 and 4 as a pair are next to another digit. This has to be 8 or 9 on the Dutch whisper line. I guess pink could go something like there, right? And then dark goes there. Or this could be like an orange in the region, and he goes to a separate region, then goes to a separate region. So this could be pink. Actually, can that ever be pink? I think the answer to that is no. It can't be medium gray. Can't be pink. Can't be dark. Huh. Interesting. So this is kind of like its own region right now. It could go here, then here, and then here again. And in that case, or dark would... Oh, it can't do that. So this can't be 5 because of the 5 in the column. But also, If it tried doing this, that would mean this is a separate region. This is a separate region. Where is the dark going to go? Orange has to go this way. Pink has to go this way. Dark would be blocked off that way. So it cannot go to this part. Because if it did, orange wouldn't be able to go anywhere, right? Excuse me. So this, again, if it goes this way, orange can't go this way, so it has to go this way. It blocks off that. Pink has to go that way, so then the dark would have to go this way. And then there's only 6, it would have to go here, but we already know this is a separate region because this is only 4 in size. So that does not work if it goes this way. It has to go this way. So this has to go this way, then this way, and those are both boundaries. So this is a boundary, this is a boundary, which means this is also a boundary. So whatever is here has to go this way. That means dark has to go down here. Since dark goes down here, that means this is a boundary here. So this must be orange going this way. Therefore, what region is this part of? It has to be part of pink. So this is then the regions, that's a boundary. We have 1, 2, 3, 4, 5, 6, 7, 8 at maximum. So this has to go out here. And it's 9. This is a boundary. This is a boundary. Orange has to go this way. This is a boundary because these are different segments. And they have to be different segments because otherwise they would have the same count. This could be dark, except that this is already one to, so this has to be dark going this way. One, two, three, four, five, 6. If it tried to go here, that's 7, 8, and 9 at max, and that's not going to be a segment of 3 in length. That's of 5 in length at least. So this has to be a separate region. So this is blue. This is dark. We have 1, 2, 3, 4, 5, 6, 7. That's 8, and it can go any other way here. So these are boundaries. This cannot be 9 here because of the 9 in the dark region. This has to be 5 or 6. And it's next to both 1s. So that fits for either purpose. These are all pink. This cannot be 3. This can't be 8 here because of the 8 in the column also. Okay. Pink does not have to go out here because we could have 9 here. So that's fine. 1, 2, 3, 4, 5, 6, 7, 8. The dark gray. Okay. What else do we have? This is 1, 2, 3, 4, 5, 6. We have at most 7, 8 here, so we have to have at least 1 here, but we don't know which. This pink needs access to a 1, and none of these can be 1. So this pink does have to go out. So therefore this orange has to go out here, this blue has to go out there, because otherwise it doesn't form any other region. This is a boundary, this is a boundary. This could be the 1. In fact, it probably has to be. We have 1, 2, 3, 4, 5, 6, 7, 8. It can only go 1 more in any of these directions. I guess 1 could be here. So one of these is a 1 guaranteed. We just don't know which. Oh, it can't go this way. Dang it. Oh, that's bad. That's very, 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 very bad. It can't go that way because it would touch itself. It has to go this way, but that doesn't make any sense. Let's try it, but I'm pretty sure that doesn't make any sense. Can't be pink. This is problematic. That's bad. That's really bad. Okay. Huh. Huh. How does that work then? Oh, couldn't this be 5? This has to be 5 then. Okay, so I think the logic there was incorrect. No, because the 5 has to be next to 1. Yeah, there's no way that that can happen. Right? This is not good. Yeah, this could technically be 5, but I don't think it works because again, the rest of the this has to be a separate region. And then this can't be gray because that would close off this region. So this still has to be 4. 1, 2, 3, 4, 5, 6. So it's guaranteed to be that. It cannot touch itself here. It can't do anything like this because then it would touch itself. Or consider it basically being touching itself. So it has to go this way. This is guaranteed to be 1 or 3. Right? Because it's only this segment. This is 1 or 3 because it's next to 6, 7. And this can only be 6 or 7. Because it would be touching itself if it went that way. Right here. And the problem is this is a region. If it's just 1, how does that form a region? It can't be part of the gray region. Oh, unless it is part of the gray region. It has to be part of the gray region then. Yeah, so it could be 6 blank 1. And we just showed that 3 doesn't work here. Right, because then the 4 gets into some weird shape here, and that's not possible. So this must be then 1. And this must be part of the gray region. Otherwise, it just... Yeah, and then this is a separate region. So will be the pink, I guess. This will be the medium gray. This has to be something else. It could be pink or dark. That's 1. That makes this 3, which makes this 7. So this is next to 8 or 9 here. This can't be 1 or 3. The rest of the region is what? The rest of row, this can't be 7, is 4, 5, 6, 8, 9. Okay, this can't be 1. This is either a low, so it's 2 or 4, or it's 5 or 9, right? Okay, so then this is part of a region. It cannot be, well, technically it could be 5. Okay, so then this is a border. So we just showed that the 3 does not work here. That's very interesting. So 1, 2, 3, 4, 5, 6, 7, 8. We have a ninth, and that so this is either medium or it's pink. This could all be part of pink. So this has to be a border here. Right. That was tricky. Anyways, this could still be pink. 8 or 9 is only next to 2 or 4. Right, it's next to 3, so this is 8 or 9 specifically. This is 2 or 4. What digits are in the gray region? 2, 3, okay, no 3. 2, 4, 5, 6, 8, and 9. Obviously, it's next to 2 or 4, so this can't be 2, 4, 5. It could be 6, 8, or 9 here. But if it's 6, only one of these could be 2, and that doesn't work. So this has to be 8 or 9. That's an 8, 9, 8, 9 pair in the medium gray region. So this can't be 8 and 9. This can't be 8 or 9. It's 2, 4, 5. Hmm. Hmm. Uh, 1, 2, 3, 4, 5, 6, 7. So again, this can never be 9. It's 4 or 5 here. It can never be 5, because if it's 5, that would have... Well, I guess it could go that way, technically, right? 1, 2, 3, 4. No, because then that would not be 5. So if it goes this way, it has to be 4, right? Because that's the max you can have in the same segment. And then this is a different segment. Or if we try to go this way, it can't be 5, because 5 can only be between 1 and 9 on a Dutch whisper line. And neither of these is 1. So this is guaranteed to be a 4. So this is still 4. We just don't know which way. And since this could be pink here, it's very likely this is pink. That actually works. This is 1, 2, 3, 4, 5, 6. So that's at, this is again at most 3, so it's 1 or 2. But this could be now 4 going this way, and that's fine. Or 4 going this way, and that's fine. When you had it as a 3, that didn't work. Because this 4 would have to go like here, or it would have to touch itself, which is not allowed. That's the reason why we know this is 1 instead of 3. I just assumed it was 3 because I just assumed that this was a separate region, but I forgot that it could still be the medium gray region. And it has to be now, because we showed that 3 doesn't work here, so this has to be medium gray. Wait, this isn't 7. This has to be... that's problematic. 1, 2, 3, 4, 5, 6. This segment isn't 7. Okay, so that's problematic too. So that's not working either. What is going on then here? This is weird. So neither of them work. Uh, yeah, neither of them work. That's problematic. Then are we doing something wrong here? Okay. We know there's a border here. It's harder because right now I can't, I'm using the coloring for regions. Normally what I usually do for loops is I have the coloring set aside for the loop. So I can tell what can and cannot be on the loop or not. But I'm having problems with that. Um, this is a boundary. Again, the region can't has to be 9 in size. So this region must go this way. There, and we know the loop goes that way too. So the loop has to go here, loop has to go here, loop has to go here. This must connect to the loop, so that's looping that way. These must be different segments because otherwise they would be the same number. So this has to be a different segment here. Therefore, we know this is 2. 2 is next to 6, 7, 8, 9. This cannot go this way. This actually has to exit out, so it goes that way. This is a separate segment. We have medium gray here. This is segment is at least 6. So again, can't go straight here. That's only 3 in size, and then this has to be a separate segment. So it must go here, which means this must go here, which means this must go here. So this is a boundary. Why can't this be 1 again? Maybe that's the problem. Maybe this can't, this has to be 1. Why can't it be 1? I guess maybe that was the problem then. Yeah, this could be 1. Hmm. It's only 1 or 3. This has to be 1 or 2. Well, actually, doesn't have to be. This is different segment than this, definitely, but it could be go here. So that's... Oh, no, this has to go this way. Right, and then it would touch itself if it went this way. So this does have to go that way. That's the reasoning. Ugh. This is at least 6. This cannot go down to here because then it would touch itself. But it has to go at least here because this is only 1, 2, 3, 4, 5 in segment length. So this must go down. It cannot go down here because it would touch itself here. So this cannot be 1. This is 3. And it has to go, I guess. No, this medium, this light has to go here. This goes this way. It cannot touch itself, so then it goes here. It has to go... Just can't touch itself that way. So it has to go like that, and then here, then here. So this is 6 or 7. next to 1 or 3. This is only 1 or 3 in size, right? Because this is guaranteed to be 6 here. 1 and 3 is only, it can only go this way. So this is 5 through 9 here, and this is 5 through 9 here. This must be, cannot be 1 or 3. It has to be 5 away from, sorry, 4 away from 5, 6, 7, 8, 9. So it's 4, 5, or 9 here. This is 5, 6, 7, 8, 9, because, or 4, 5, 6, 7, 8, 9, 4, 5, 6, 7, 8, 9, 4, 5, 6, 7, 8, 9. This can never, if this is 3, that means this is 7. So then this is a separate region and is 1, but it can't exit out. So this can never be 3. Sorry, this can never be 7. If this was 7, that's 3. This would be 7 going this way. It can't touch itself again. Boundary, boundary. This has to go that way. It's green. This is a boundary. So this loop goes that way, then has to go that way. This is 1 or 2, because otherwise it goes to one of these, then it has to have a boundary. This green goes down. 3 is next to only 7, 8, or 9 on a Dutch whisper loop. These are the digits 1 through 5, so therefore that forces this to be 5, and that 1, therefore this is 9, so this cannot be 9 here. 1 and 3 can only be next to 7, 8, or 9 here. If we had 1 here, and this is 3, and that's 7, this is 1, 2, 3, 4, 5, 6, 7 in length. This would be 1, but it doesn't have a region, because neither of these are part of the region. So this cannot be 1. This has to be 3, which makes this 1. That leaves this as 7, 8, 9, 7, 8, 9. This is a high digit, so it must be next to that. So this has to be, it's 4, 5. This is 3, so it has to be these 3, and it has to be its own region, and it has to get out. This is a boundary here. Ugh, we still run into the same problem. This is a boundary here. Rest of row 2 is 1 through 6. No 1 here, 1 through 6, 1 through 6, because of the 7, 8, 9 triplet in the row. This can't be 3 because of the 3 in the region. This is pink or medium. Gray. This has to be dark. Why? Let's go this way, go that way. Cannot go this way, could go this way. But this can't ever be 5. Because it would have to be next to 9 and 1 in the same row. And this can't, neither of these could be 9. So this must make this as 4. So this is an 8 and 9 pair here. That eliminates 8 and 9 of the rest of the row. So this can't be 8 or 9. This can't be 8 or 9. This can't be 4. So this must be between these. So this has to be 5, which makes that 9. That forces this to be 1. This is all the same region because the segment length is 4. This cannot be 1 here. Why did I have this as 1? Oh, because this was a 2-4 pair. That's the problem. This is 1 or 2 in length, size. And the problem is, for this gray region to actually make sense here, it has to be a 2-4 pair. Does it? Can it be? No, it can't be 5 and 9. I guess it could be 9, 5, 9. I think that's what it has to be. We showed 1 can't be here. We showed that 1 can't be here. I think this has to be something like 9, 5, 9 here. So I think that is what we are leading it to. Well, we've shown that we really have to go down this path. We tried this being 1. It has to go this way. If this is 1, this is a separate region than the dark, because it can't be 1 here. And then this would be orange going that way. This would have to be a separate region going that way. The pink would go that way, and the dark region is too small. So this cannot be 2, 4. So the digits next to 7, 8, and 9 has to be 1 through 5. This can't be 1, though. It can't be 3. Same, 2 through 5. This has to be a 4, 5 pair. If this is 5, this can't be 5 next to none of 1 and 9. So this is 2 or 4. So we showed if this is a 2, 4 pair, this becomes 1, and this is problematic. So this can't be 2, 4. It must be 4, 5. So this is 4, this is 5, this is 9 and 9. That makes this 8. That means this can't be 9. This is 8 to be next to the 4. This is a 2, because we showed that 1 doesn't work. So this is the same region. And that allows us, so this is definitely a border here. Well, here at least. And this is both orange, I guess. I guess this, and this is, this could be dark, actually. But it has to be 2, so this is 6, 7, or 8. So it cannot be dark, because the dark has to go out here. The pink has to go out here. So that means this is a border. These are borders. The dark has to go out again. 1, 2, 3, 4, 5, 6, 7. So this is orange or dark. This pink has to go out again. So we 1, 2, 3, 4, 5, 6. This can't be 4 because or 5 because of the dark region. This cannot be part of the dark region because we can't have enough to fill that, right? It would be at most, this is already 6, right? 1, 2, 3, 4, 5, 6. So this would, if this included this, that would be 7, 8, and 9. So it'd be 3 in most at size. So this has to be like a blue. So that means orange has to go down here. It has to continue here. This is blue. This is orange. This orange must continue down here. This has to be 6, 7, 8. It cannot be 9 because of a 9 in the row. That means the remaining digits in this 5 eliminates 5 here. It's a 6, 7 pair. The rest of the digits in row 3 have to be 1, 6, 7, 8. Okay. And this can't be 1 because of the 1 in the column. This can't be 8 because of the 8 in the column. This can't be 1 because of the 1 in the region. Where is the 1 in row 3? It has to be here. So this is 1. This is a boundary. This is a boundary. The dark has to continue here because that still doesn't have enough digits. This is a boundary. So we have 1, 2, 3, 4, 5, 6, 7, 8, possibly 9. So this is a boundary here. So the dark does not have to have another set. The pink can go somewhere, has to go somewhere, but it could go that way. So we don't know whether it goes that way or that way. The blue has to get out, so therefore this is blue. That means this is orange here. So the blue has to be already 6 through 8. So that's at least that way. This is what? 1, 3, or 4 is possible. Can't be 1. So this is 3 or 4, which forces this not to be 6. This has to be 7 or 8 in length. Well, to do that, I think it has to block off this, right? So this is one, this has to be 1, 2, 3, 4, 5, 6. So it could be 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. This is guaranteed to be one. Okay, so I think this has to be blue either way. So obviously it connects here, then connects here. This is going to be like yellow. This specifically here. Three or four is next to 7, 8, or 9. Can't be 9. This is a 7, 8 pair. So this could go one more here, but it cannot continue here. This loop can't go here, so this... So it cannot go here, because if it goes here, then here. The problem is this would have to... I guess this could be 1. So it could actually go there. We have guaranteed 1, 2, 3, 4, 5, 6, 7. 8 and 9 is possible there. But, so if this went 8 and 9, so I don't, this could be orange. 4, 5, 6, it could be 7, 8. So it could be 1, 2, 3, 4, 5, 6, 7, 8, and 9, technically, or 7, 8, and 9, or 7, 8, and 9. So orange can get to here. But if it tried going here, the blue does not connect to here, which it sort of has to. And it has to be 7 in size at least, to be next to 3 or 4. So this can't be orange. I don't think that can be orange either. If it goes orange here, this is not, it has to touch itself to get back here. So same with this. So orange can be all of this. Blue can actually be all of these too. Blue could be here. Dark can be only one more here. So dark is one of these two. This could be dark. This could be pink. This could be pink. We have 1, 2, 3, 4, 5, 6 guaranteed. So it's 7, 8, 9. So that could be pink. This could be pink. Any of these could be pink. It cannot be here because that would block off this region. This is 1, 2, 3, 4, 5, 6. And in fact, this has to be a 6 because this is 6 in size. This has to be 7. That eliminates 6 here and 6 here. This becomes a 7, 8 pair, so there's no more 7 or 8 in the rest of the light gray region. This 8 eliminates 8 here, so this is 7, which makes this 8. So this can't be 8 here, this can't be 8 here. It's a 6, 7 pair. Pink cannot go all the way here. That would be this 1, 2, 3, 4, 5, 6, 7, 8 medium grays at most. So this cannot be pink. Medium gray can go here. It's 1, 2, 3, 4, 5, 6. So it could be 7, 8, 9. 7, 8, 9 potentially, or 9 here. It cannot go through here, so that doesn't work. This could technically be light. 1, 2, 3, 4, 5. This can't close off here. So the light could be here. These could also be light. This could be light. This cannot be light because that would close off the medium gray. This could be light. This could technically be light. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a 9th potentially that could be 5, 6, 7, 6, 7, 8, 9 going there is possible. Blue can of course go this way. Cannot cut off dark. Actually, it could cut off. This is, we don't know. Technically, blue could go here. Actually, can it? 1, 2, 3, 4, 5, 6, 7. Yes. And then it has 8, 9. Anything that's not part of this thing, it could go 2 away from. So it could be 2 that way, 2 that way, up to blue here. Obviously, these could be yellow. These could technically be yellow also. Because it could be 7 this way. This could be some sort of red. Could it be gray? No, because it can't be 1 in the gray. Technically, it could be red. It cannot be green. Green could go here, though. This digit cannot be 1, 3, 8, or 9, so it's 2, 4, 5, 6, 7, possibly. The orange has a 2. Where is the 2 going to be then in column 9? It has to be part of the blue. So this must be a 2 here, because there's no other place. Well, I guess... no. Can it be? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Or 8. If you tried 1, 2, 3, 4, 5, 6, 7, 8, and 9, the orange would be large enough, right? 1, 2, 3, 4, 5, 6, 7, 8. So this has to be the blue. Since this is blue, it must connect here, so this is blue. These are the 2x, well, it could be just straight down. If it goes straight down, that's 1, 2, 3, 4, 5, 6, 7, 8. We need 1 guaranteed at least here. So either this is orange or this is orange. So this cannot be the way. It has to go this way. So this can't be yellow. This is blue. It must go this way. Therefore, this is always going to be 7. So this is 7, which forces this to be 8. That has to be 3 to be in between 7 and 8, because it can't be 4. We have 1, 2, 3, 4, 5, 6, 7 guaranteed. Both of these could be orange. We know these 2 are not on the loop. So basically the 2 blue have to be on the loop, so none of these can be blue. This is a 2 here, guaranteed. Because there's no other place for the 2 to be in column 9. We have to have how many digits on this loop? 7. Since there are 7, there is no 2. We have guaranteed 7, 8, 9. I think we have to 1, 5, and 9 somewhere, right? Well, that's okay. It's either missing a 6. These digits cannot be 4. It can't be 2, 3, 7, or 8. So this is 1, 5, 6, or 9. This digit is also cannot be 2, 3, 7, or 8, 1, 4, 5, 6, and cannot be 9 here. The orange needs a 1 or 5. 1 and a 5. So the 1 is guaranteed to be here. The 5 is also guaranteed to be one of these three. So this can't be 1 or 5 here. It's 4 or 6. Okay. So that means 1, 5, and 9 must be guaranteed to be on the Dutch loop. So it has to have 1, 5, and 9. So the 5 is between... Well, it doesn't have to be. And we have 1 out of 4 or 6 on the loop. 6 cannot be on the loop. If 6 is on the loop, the problem is what digits... Well, 6 could be here, technically. So it could be 6, 1, 5... That's not going to work. So say 6 was on the loop. The only place 6 could be, 6 cannot be next to 8, can't be next to 5 through 9. It can only be next to 1, and it can't be next to 4. So 6 would have to be here. But that's problematic, right? If this is 6, it has to be next to the 1. The 1 would be next to 5 and 9, but the problem is neither 5 or 9 can be next to 8. So that's the problem there. That means this can never be 6. This has to be a 1, 5, 9, and the last part has to be a 4. And that has to be next to the 8, and the 4 cannot be in column 7, so the 4 has to be here, which means it connects here, then it connects here, then it connects here. So this is not orange, this is blue. This can't be blue, that's orange. This can't be dark, it must be orange, because we need access to a 5 and a 1, and they can't be in column 9. So this is 5, that's 1, this is 6. This can't be 1. 4 can only be next to 9, so this is 9. This is not yellow, this is blue. This can't be blue. Therefore, the dark has to be one of these two regions. We don't know which. This can't be pink, though. Yellow could actually go up here, so that's fine. But pink cannot go here because that would block both of these possibilities for the dark region. So yellow can go all the way around here. This is a region then. So we have the orange region. We have the blue region. Oops. This must be 5 because it can't be 1 here, so this is 5, which makes this 1. 1 is next to 5 through 9. Cannot be 6 or 8 because of the 6 in the row and the 8 in the column. This 5 eliminates 5 in the rest of the row. These digits must be... what? 3, 4, 6, 7, 8, 9. And this can't be 7 or 9. No 3 here, no 8, no 4 or 9 here. This 7 eliminates 7 here. Technically, yellow could go over here, too. Anyways, okay, the rest of column 1 has to be 1, 4, 6, and 8. This can't be 8 because of the 8 in the row. This can't be 4. This can't be 1. This can't be 1 or 6. Okay. This is 1, but we don't know where it goes. This cannot be 1. It's 2, 3 at least. It could be... So this 1 is next to a 6, 7, 8, or 9, which is next to that digit. Or 1 is next to 5, 6, 7, 8, 9. So this could be 2, 3, could be 5, or 9. We don't know. It's very likely 2 or 3, but we're not really sure. This digit cannot be 1, 2. It could be 3, 4, 5, no 6, no 7, no 8, or 9. So this is 3, 4, 5 here. Rest of column 7 has to be 2, 3, 6, 7, 8. This obviously can't be 7 because of the 7 in the row. No 3, no 8 because of the 8 in the row. Green can go up to 5. So technically this could be green. Well, green could actually even go up to here. And then we have red. So this could be green, red, or yellow. This is also green, red, or yellow. Technically, I think this could be red. Can this ever actually be red? These would have to be a different region than this. This can't go this way. I guess red could technically go around that way. I don't know. This could be red also. This could technically be red. It can't be pink. It can't be dark. Can't be green. So green can get up to here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Technically that works. Oh, no, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can't be green here. Okay. 5, 7, or 9. That means this is low. 3, 4, or it's 5, 9. This can't be 3, 5, or 9. This has to be a 4 then. So that forces this to be 9 here. This 4 eliminates 4 here, so this is 8, which eliminates 8 in the rest of column 1. This must be then 5, 6, and... no. 3, 5, and 7 in the rest of column 9. This can't be 7 because of the 7 in the column. This 4 must be next to an 8. Or 9. It can't be 9 because of the 9 in the yellow region already. This can no longer be yellow because it would be part of, it would have the 2 8s. This can't be 8 because of the 8 in the row. The rest of the row is 2, 3, 4, 6, 7, 9. This can't be 4 because of the 4 in the column. No 9 because of the 9 in the column. No 9 because of the 9 in the column. 8 is only next to 2, 3, or 4. This couldn't be 7 anyways. Rest of column 5 is 1, 2, 6, and 7. This can't be 7 because of the 7 in the row. No 1 because of the 1 in the row. Everything else seems okay. Pink needs access to a 5, but the 5 could be here or here, or one of these, or not there. One of these, I guess, or these. What digits can this be? Actually, how many 8s do we have? We have a decent amount of 8s, right? The dark needs access to an 8, so the dark will have one of these be an 8. But that's wide variety still. The green needs access to an 8, and so does the red region. Okay, rest of column 3 is what? 2, 3, 5, 6, 7, 9. This can't be 7 or 9. This can't be 3 or 5. 2, 3, 5, 6, 7, 9. No, 9 here. Can this ever really be 9? I think the answer to that is like no. Can this be 5? I guess. 1, 2, 3, 4, 5. Yep. Can this ever be 9? Again, I don't think so. How does it do something like that? Yeah, I don't really know. I think this has to be at most 5. This is 2, 3, 4. That means for this to be low, this would be high, technically low, and then high. I guess it could be 5 here. And no, it can't be 5. It would have to be high, and then it could be 1, and this could be 5. That's possible. This is low also. So this has to, whichever one has to be in the loop has to be high. Technically, it could be 5, 1, then a high digit, then a low digit. That's possible. If it tries going this way, this would have to be high. Okay, so it cannot go this way. If it tries going this way, the problem is that it would basically loop here. This would be high. This would have to be guaranteed low or 5. But then none of those are 4 or more away from 2, 3, and 5. So it cannot go this way. It has to go this way then. So it has to go this way. And then it can't go this way because that would also be low, right? So this is 6, 7, or 8 to be next to 2, 3, or 4. And I think it has to go this way 1, and this has to be 5. Right. Because otherwise this doesn't work, right? This would have to be 2, 3 next to 2, 3, or 5. So it has to go this way. So then it has to go this way, which means it has to go that way. This would have to be a 1. And this would be 5. So this would all be the same region. It would go to a 9 in one of these two spots, which would be next to 1. That's fine. So this is all the same region. So it cannot be yellow. Can't be pink. Can't be light. So it's or medium gray. So this is green or red, guaranteed. This cannot be green because we have a 5 in green. So this has to be the red region. So this is red, which means this cannot be red. That's yellow. And then one of these is red. This can't be red, so this must be light. That's the only color that can be. Can't be medium. So one of these is red here. Green then cannot reach here. So green can't be any of these because it can't get past the red or the white, the light, essentially. The red has a 1 also, but this could be 1. So, oh, this 1 eliminates 1 here. So this is a 4-6 pair, which eliminates 4 and 6 in the rest of the column. So this can't be 6, this is 1. So this can't be 1 here because of the 1 in the row. We should have all 1s. No. This can't be 1 either. But we have 8 ones, right? 1, 2, 3, 4, 5, 6, no. Yeah, 7, 8. We know where the last one has to be. It has to be in this space because that's the only row and column which doesn't have a 1 yet. This cannot be pink. It cannot be gray. Uh-oh. That means it's yellow? I guess yellow can reach there. It has to be yellow because that's the only region that doesn't have a 1 now. So this has to be red here. The yellow has to reach here, which means it must go... Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. So this cannot be yellow here. Yellow technically could be this way. The pink needs to exit out. This can't be pink. So this is 6 here and 7, 8 at most. So this must be pink, which means this can't be dark, which means this has to be dark. So that's the full dark then for... that's the full dark region. Therefore, this is pink. 1, 2, 3, 4, 5. This has to be yellow to connect. So this has to be yellow. And it could connect this way too. Red cannot go here because that would block off the yellow. We have 1, 2, 3, 4, 5, 6, 7 guaranteed. This can't be pink because it's blocked off. We have 1, 2, 3, 4, 5, 6, 7 guaranteed. This is 2, 4, 5, 6, 7. Cannot be 5 because of the 5 in the row. Okay. This can't be yellow anymore. It can't be red because red has a 1 also, so this is definitely green. This is 1, 2, 3, 4, 5, 6, 7, 8. So the yellow only has 1 step that it can get to. So it's one of these. So it's 1, 2, 3, 4, 5, 6, 7, 8. So then it has to connect to here. So this can't be red. This is all yellow, which means this can't be yellow. So this is pink. Therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 pink. The yellow's all done also. This is 2, 6, 7 triplet. Eliminates 2, 6, and 7 in the rest of the row. This can't also be 4 either, so this is 3, which makes this 5. So none of these can be 5. The pink is all full, so this can't be pink here. This is the medium gray region. And so the medium gray region only has access to 1 more. 1, 2, 3, 4, 5, 6, 7, 8. If it goes here, that would block off this cell from any other region, so this must be medium, which means this can't be medium. So the medium is done also. We have 1, 2, 3, 4, 5, 6, 7 in the light region. We have only 2 more. You can only go 1 here, so it would definitely have to be at least 1 here. So this is the same region, which means it cannot go that way. It has to go this way. So this must be the red. So this is 1, 2, 3, 4, 5, 6, 7, 8, and this must be 9 for the light region. So that's done. So this goes this way and then connects that way. So that's the loop. This is a boundary, so this is red. We don't have any more yellows in that quadrant. So this is just red or green. This is red, so this can't be red. This is green. This can't be light anymore. 5 is next to... This has to be 9. So this is 9, which eliminates 9 in the rest of the row. This can't be 2 in the light region. This can't be 2 in the light region. We have what? 3, 4, 5, no 7. This can't be 7. 3, 4, 5, 6, 9 in the rest of the light region. This can't be 3 because of a 3 in the row. This must be, what, 2, 4, 5, 6, 7 in the rest of the row 6. This can't be 4 because of the 4 in the row. This can't be 5 because of the 5 in the row. 1 to 6, 7, 8 to 3, 3. This can't be 3 because of the 3 in the row. This can't be 3. The green region... We should have actually 8 8s, right? No, we have... Well, where's 8 in column? 4. Cannot be in the dark region because or the medium gray region because we already have an 8 there. Can't be in the light region, can't be yellow. So it has to be in the red region, and it must be here. So this is 8. Which eliminates 8 here. That means this can no longer be red, because that would make 2 8s in the red. So this has to connect here, to otherwise it would block off this region here. So this must be green. That means this is 2 or 7 here. And we need another 2 or 7 in the other green, which could be any of these. This can't be green anymore, so this must be red, which means this has to connect that way and be red. This can't be 9, then. This can't be 9. This can't be 5 because of the 5 in the column. This can't be 5 because of the 5 in the column. Okay, let's check the Dutch whisper line. 2 is 5 away from 7, 4 away from 3, 6 away from 9, 4 away from 5, 4 away from 1, 8 away from 9, 4 away from 5, 4 away from 1, 4 away from 7 away from 8. It's going to be at least 4 away from 2 or 4, at least 4 away from 2 or 4. 8 is 4 away from 4, 5 away from 9, 8 away from 1, 4 away from 5, 4 away from 9, 5 away from 4, 4 away from 8, 5 away from 3, 4 away from 7, 5 away from 2, at least 4 away from 6 or 7, at least 5 away from 6 or 7 to 1, 1 to 5 is 4, 5 to 9 is 4, 9 to 4 is 5, 4 to 8 is 5, 8 to 3 is 5, 3 to 9 is 6, 9 to 5 is 4, 5 to 9 is 4, 9 to 4 is 5, 4 to 8 is 4, 8 to 1 is 7, 1 to 6 is 5. This is 2 in length, this is 3 in length, that's 1 in length, this is 5 in length, we don't care have anything there. This is 1, 2, 3, 4, 5, 6, 7 in length, this is 2 in length, this is 4 in length, this is 3 in length, and this is 6 in length. So all of the loop is satisfied. Okay, this digit cannot be 4 or 6. It makes a 2-3 pair in the gray region. That eliminates 2 and 3 in the rest of the column. So this can't be 2. It has to be 4. This can't be 4, 5, or 9. So this is 6, which makes this 9. That makes this 3, which makes this 4, and this 5. This 3 eliminates 3 here, so it's 2, which makes that 3. This can't be 3 or 4. Okay. This can't be 6. And this can't be 9. Where is the 5 in row 7? Can't be here because of the 5 in the column. And can't be here because of the 5 in the columns also. So it must be here. So this is 5, which means this can't be 5 here. It's This can't be 5 or 2. This can't be 3 or 2. This can't be 3. Okay. Where's the 3 in the dark region? None of these can be 3 because of the 3's in the row, so this must be 3 here. That means 3 cannot be here. Where's the 3 in column 9? It can only be here. So this is 3, which means this can't be 3. Couldn't anyways because of the 3 in the column. This can't be 4 because of 4 in the row. Neither can this, neither can this. This 4 here eliminates 4 here, so this is 6, this is 4. That eliminates 4 here, 4 here, 6 here, 6 here, 6 here. We have a 2-7 pair in row 8, which eliminates 2 and 7 in the rest of the row. So this can't be 2 or 7. This is 9. We have a 6-7 pair in column 9, which eliminates 6, 7 in the rest of the column. So this can't be 6 or 7 here. We have a 2-7, 2-7 pair here. This 3 eliminates 3 here. So this is 7, this is 3. This 7 eliminates 7 here, so it's 2 and 7, which makes this not 7, so that's 2. This can't be 2 or 7, so it's 6. This can't be 2 or 6, so it's 7, which makes this 2. This can't be 2 or 7, so it's 6, which makes this 7, which makes that 2. This 7 eliminates 7 here, so it's 6, that's 7. This 2 eliminates 2 here, so it's 6 and 2. Okay, this red is a 7, so this can't be red. This must be green. This can't be 6. This can't be green and 3. So these are the regions here. That means this 6 eliminates 6 here, so it's 4. Which means this can't be 4, that's 8, which makes that 4. This can't be 2 or 7 because of 2 or 7 in the column, so it's 8, which makes this 6. This can't be 4 or 2, so that's 7. And that's how you solve it. Ugh, that was hairy. Particularly this part. I messed this part up pretty badly, actually, multiple times. But I guess you sort of had to go through that way anyways. Because otherwise you wouldn't be able to, like, you have to eliminate those possibilities. So I guess it was good going that way and eliminating those possibilities. I just wish I had recognized that those possibilities were not correct. Or could possibly not be correct. This was challenging, actually. I don't know. Maybe it was just because, yeah. I'm not the best at Dutch whispers. I'm okay with them, but I'm much better with German whisper lines. And so I will sometimes have some blind spots with my Dutch whisper lines, particularly like this 959. That was the thing that was kept me sort of stuck. And like where I ran into the contradiction here, right? So you'll occasionally have blind spots, and it's good to figure them out. And I guess this one's mine for Dutch whisper lines. It's the 959 situation, right? The thing is, again, you would have to test this out. You'd have to see, oh, well, if I tried to have a 2 here, that makes this 1, but then this doesn't fit this rule set, right? You can't have a region that would go this way, and then go this way, and then this is separate 1, and then the dark region would be blocked, right? But then I noticed that I messed up this, right? This could still be 1 and 3, but then until I've proved that this could never be 7, right? If this is 7, this could never be 3. If this is 3, that forces this to be 7, which forces that to be 1. But then this 1 wouldn't have a region for itself, and it cannot be part of the medium gray region. But you have to go through those things to basically figure that out. So I guess it's fine that I have a blind spot there, but it's not good to have blind spots, right? Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.